Good morning, friends. I hope all of you are fine at your home. First of all, let me wish you a very happy Raksha Bandhan to all of you. May all your wishes come true. So, as you all know, that I try to give you the solutions of previous year questions which were asked in CSIR NET and GATE Physics exam. So today we will be discussing a question which was asked in a NET June session in 2012 year. Let us first read the question and try to understand what it is asking. A variational calculation is done with the normalized trial wave function psi x is equal to root 15 upon 4 times upon a to the power 5 by 2 into a square minus x square for one dimensional potential well, which is given by the expression Vx is equal to 0 when mod x is less than equal to a and Vx is infinite when mod x is greater than a. This is the one-dimensional potential well. The ground state energy is given by, here 4 options are given, we have to choose the correct option. Now friends, let us start with the basics of quantum mechanics and especially the one-dimensional potential well. The diagram is given by this. This is Vx and y-axis and x along x-axis. This is a and minus a. Vx is 0 when x is between minus a to a. From minus a to a, Vx is 0 and it is infinite when x is less than a. This is x less than a and x greater than a. Here in this region, Vx is infinite and in this region, Vx is 0. So this is one-dimensional potential well. Now let us proceed ahead. The expectation value of energy in the quantum mechanics is given by bra psi h of ket psi upon bra psi ket psi. This is the bracket algebra of writing the expectation value of the energy, and which is equivalent to writing this bracket algebra expression is equivalent to writing this form psi star h of psi dx, and the integration will be from minus infinity to plus infinity. It means the whole space region upon bracket of psi is written as psi star psi dx, and the integration limit is from minus infinity to plus infinity. Here we have to note that since these are the normalized trial wave functions, so this expression denominator 1 will be equal to 1, and now the remaining expression is for the energy expectation value E is integration psi star h of psi dx, and the limits will be from minus a to plus a because we are focusing and concerned about this region only. Here wave function vanishes. Now next thing is Hamiltonian is given by T plus V, kinetic energy plus potential energy, and here it is in terms of the operators. So the Hamiltonian is given by T, and here T is p square upon 2m, which is momentum, plus V. Here V is equal to 0. In the region from x belonging to minus a to plus a, V of r will be 0, as it is clear from the diagram and the expression for the one-dimensional potential well. So we have taken V equal to 0. Now we know that what is the operator P given as? P is given as I h cross of del, and P square, in this manner P square will be written as minus of h cross square del square because iota square is minus 1. So P square will be given by the expression minus h cross square del square. Now h is given by the expression minus h cross square upon 2m of del square upon del x square. This will be the expression for the Hamiltonian h. Now h of psi is given by nothing but we have to add psi on the both hand sides. H of psi will be minus h cross square upon 2m del square upon del x square of psi, and according to question psi is given by under root 15 upon 4 a to the power 5 by 2. So h of psi will be this, and after doing the differentiation and solving it twice, we will get h of psi is equal to minus of h cross square upon 2m, and double derivative of this wave function with respect to x will give us minus under root 15 upon 2 times a to the power 5 by 2. Now let's move ahead. Expectation value of energy is minus h cross square upon 2m, integration from minus a to a. See the expression for the E, psi star h of psi dx. from the integration limit minus a to a. So this will be, now see here, this will be psi star. Since it is a real function with no complex values, so plus or minus I will remain the same here. The conjugate term will also remain same here, and this is equal to h of psi term. This is psi x and this is h of psi dx. We have just replaced, substitute the values of those terms in the energy expectation value. This will be psi and this is h of psi. After simplifying it and doing the integration in the limits from minus a to plus a, we will get the expression as h cross square upon 2m 15 upon 8 a to the power 5. Here integration of a square will be a square x minus x square integration x cube by 3 in the limits from minus a to a. After simplifying it, we will obtain energy expectation value h cross square upon 2m 15 upon 8 a to the power 5 into, this will be solved as 4 upon 3 a cube, value of this integration. Now after simplifying this expression, we will obtain the energy eigenvalue E is equal to 5 h cross square upon 4 m a square. So the correct option is D. Let us see. This one is the correct option here, 5 h cross square upon 4 m a square. So I hope friends you have understood the solution of this question. Thank you.